Alright, this is section 2.3, the real zeros of a polynomial function. And we're actually going to, before we get to polynomials at all, we're already familiar with the term zeros. Another word for zeros is roots. And zeros tie closely to factors. We covered that in the last section. But I've actually got a very old long division problem, because there's some similarities here, and I'm sure you remember if you were to do this long division problem out by hand, you would ask yourself, 4 goes into 6 how many times? You would say 1. 1 times 4 is 4, and you do a little subtraction. So 6 minus 4 is 2. You bring down the 5. 4 goes into 25 6 times. 6 times 4 is 24. You would subtract. 4 times 12, 4 goes into 12 3 times. Subtract again, get 0, bring down the 3. 4 goes into 3 0 times, so we still need to put the placeholder. 3 minus 0 is 3. Bring all the way down to the 2. 4 goes into 32 8 times. 8 times 4 is 32, so here there would be no remainder. When there's no remainder, we are able to say 4 is a factor of 65,235. That's an important statement. 4 divides evenly in to 65,235 because there's no remainder. Well, we are also able to take this same process and apply it to polynomial long division, which I know you have seen before in other courses, so this hopefully is just a quick review. We are asking ourselves, how many times does x minus 2 divide into 6x cubed minus 19x squared plus 16x minus 4? We ask ourselves the same question we started with, but here I focus on the first two terms. Because I have two terms here, I focus on the first two terms here, and I'm really concerned with how many times does x go into 6x cubed? The answer to that, another way to answer that is x times what is 6x cubed? So you would say 6x squared. 6x squared times just x is 6x cubed. That's the first. Now the second part, the 6x squared minus negative 2x, so let me say that again, 6x squared times negative 2 is negative 12x squared. So notice I've lined up the x squareds right here and right here. They line up, they match up in the same column, just like the x cubed here and the x cubed here match up in the same column. So here's the tricky part to polynomial long division. We are now subtracting. I am subtracting everything in that set of parentheses. That's that green set of parentheses. I'll draw them again. When you're subtracting a quantity, it's the same thing as adding the opposite. So I do all the sign changes at the beginning. In polynomial long division, these two terms should always cancel out. If you're not, you're doing it wrong. Here it's negative 19x plus 12x. That's going to be negative 7x squared. Bring down, just like we did before, 16x. All right, so we go back to the same equation. How many times does x minus 2 go into negative 7x squared plus 16x? Well, we're really asking ourselves, what times x? What times x is going to be negative 7x squared? So we would say negative 7x. Negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. Now we go to that all-important. We are going to put the parentheses in. We are subtracting that entire quantity. I think of it as adding the opposite of. Makes it a little easier. These should always cancel out. What we have here now is 2x, and I'm bringing down the 4. X minus 2 goes into 2x minus 4. How many times? Well, again, that question, what times x is 2x? That's going to be plus 2. 2 times x is 2x. 2 times negative 2 is negative 4. I do that all-important subtraction one more time. So I do add the opposite of everything in the parentheses. Lots of sign changes happening there. And I get a remainder of 0. Well, a remainder of 0 means the same exact thing it meant on the previous slide. X minus 2 is a factor of 6x cubed minus 19x squared plus 16x minus 4. That is an important statement. And in fact, what two parts would I need to multiply to get back to 6x cubed minus 19x squared plus 16x minus 4? If you know that x minus 2 is a factor of 6x cubed minus 19x squared plus 16x minus 4, then you can also say x minus 2 times 6x squared minus 7x plus 2. Well, you know, it's because this is the factor and this was the answer, we know that those two are going to be equal. 6x cubed minus 19x squared plus 16x minus 4. Alright, so this is still polynomial long division. I'm actually going to have you try this on your own. I will set it up for you, meaning x minus 1 goes on the outside. The difference here, if you notice, I can't just write x cubed minus 1. That would be incorrect. I need placeholders in division, so I do not have any x squareds, and I need to include that here. And I need to include how many x's there are, and I do have minus 1. So this is a good opportunity. Take a few minutes, pause the video. Why don't you try this one on your own, see if we can come up with an answer. I will check it tomorrow. Alright, so we know polynomial long division. Another way to do division is called synthetic division, although it doesn't work. Polynomial division will work all the time. Synthetic division only works when you are dividing by x minus k, and that's right here. If you had to divide by something like 3x plus 5, you wouldn't be able to use synthetic division. Or anything that has an x squared, and it can't use it. It only works when you have x minus k. And this minus sign becomes extremely tricky, this minus sign right here, because if you have a minus sign here, so if it was something like if you were working with x minus 2, then the number that would go here is actually 2, not negative 2. All right, so if it was x plus 2 that I was dividing by, well, then I would put negative 2 here. So that sign is always kind of tricky in the fact that it's kind of backwards. Okay, anyway, synthetic division, it works. You take this number here, whatever you get from k, you're going to include that right here. The way synthetic division works, all of your coefficients get listed 4 times right here. And all you're going to do, you always start by bringing down a. It's just going to be copying over a. Then you're going to multiply a times k. These two get multiplied. The answer goes right here. Then you add b plus ka, and it goes down. And you're going to keep repeating. Every time it goes up to here, you're going to take this, whatever this added to, and multiply it by k. You're going to add c plus the whole total, and eventually you're going to get down to the end. If you can get 0 here, it means it divides in evenly. Whatever comes right here is actually your remainder. Okay, and we'll talk about what each of these means. All right. When you use synthetic division, you must write the powers in decreasing order. I think you've probably seen that. And again, just like with polynomial long division, you have to insert zeros when you need a placeholder. So here's a good synthetic division problem to try. If I draw that little bracket, the number that goes outside here is not 3. It's negative 3, because remember we talked about that x minus k being here? This would be x minus negative 3. So the number to match up, the k and the negative 3's match up. That's the number that goes outside. All right, 1 is our first coefficient in front of x to the 4th, but the next number we write, 0. Because I need something in front of x to the 3rd. We have essentially plus 0x to the 3rd here. Minus 10, minus 2, and positive 4. All right, so we bring down. That's 1. Here it's going to be 1 times negative 3. That's negative 3. I add up. That totals negative 3. I multiply again. That is positive 9. That's negative 3 times negative 3 is positive 9. Now I'm adding up. Negative 10 plus 9 is negative 1. I go back to multiplying. Negative 3 times negative 1 is positive 3. I add negative 2 plus 3 is 1. 1 times negative 3 is negative 3. I add up, and so this one has a remainder of 1, And in fact, if I was to divide, the nice part about this, the answer to if I divided this, we don't have any variables in here, but where the variables come from, this we said is always our remainder. Well, this right here is always our constant. Constant meaning has no variable. This is always going to be x to the first. This second term will always be x to the second. This third term will always be x to the third. So what's our answer? X to the third plus x to the third minus 3x squared minus x plus 1. And then the remainder is 1. Another way to write that remainder, instead of saying remainder 1, it looks better if you write it as a fraction. 1 over what we divided by x plus 3. That's the best way to write it. So if you said remainder 1, a lot of people would know what you're talking about. So here's a good, we can do another quick synthetic division. Number outside, so you'll see how fast this can go when you get good at it. 3, 8, 5, negative 7. So here, bring down 3 times, so bring down the 3. Negative 6, add them up. 2, multiply. Negative 4, add them up. 1, multiply and get negative 2. I'm sorry, multiply and get, multiply those and get positive 4. Sorry about that, that's me making a small mistake there. We're going to fix that. 1 times negative 2 is negative 2. That's going to be negative 9. So what we get if we were to divide these, we would get 3x squared plus 2x plus 1. The remainder being minus 9 over x plus 2. That's the easy way to divide. Now, this is going to sound totally out of left field, but I actually want us to evaluate f of negative 2. And we should know how to do that. We're going to substitute negative 2 in every place for x. This is going to seem really out of the ordinary. But if you say 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7, and we try to total this up, there's going to be an important pattern that we see here. So negative 2 cubed is negative 8 times 3, negative 24. Negative 2 squared is 4 plus times 8, going to be 32, minus 10, minus 7. We total all this up. Well, these first two are 8, and then it's minus 17. That's going to be a total of negative 9. And now the key pattern is, what do you recognize? And I recognize when I did f of negative 2 being the same number that was right here. So I had f of negative 2, and I divided by x plus 2. So essentially my k value and what I took f of negative 2, those were exactly the same. Well, my two remainders, right? My remainder and my answer to the function ended up being exactly the same. You're going to notice that is true 100% of the time. And the reason that is nice, all right, so this is our remainder theorem. If f of x is divided by x minus k, then an interesting way to get just the remainder is by taking whatever this number is and doing f of k. So if you remember in the last problem, we had x plus 2. We called k negative 2. Well, f of negative 2 was the remainder. When I did f of negative 2, I was able to get the remainder, which in the last problem I believe was negative 9. So why is this important? Because sometimes I want to try to find a remainder of 0, right? Because if it's a remainder of 0, it goes in evenly. So the nice part to that, x minus k is a factor of f of x if and only if the remainder is 0. Right? So if I can do f of a number, and that number turns out, that total turns out to be 0, well then you have found one of the factors. We'll talk about that in a little bit. And a nice part, we've already talked about this, a 0, a factor, 0, a factor, all the same as an intercept. And that's something we've already talked about in our notes. You're just hearing it again one more time.